All right, welcome back everybody to the third rendering of Hack Central. This is a more recent of a program which we have started at the Schaumburg Library through our Tech Bytes program, which covers all sorts of other programs, including the Intro to Programming course and the Web Development course as well. And this is a program, if you are new, essentially we talk about more things computer science related, in the sense that we dive deeper into advanced topics, such as recently we've been doing a lot of machine learning, and today we will be doing more of that as well. And generally, we like to dive deeper into topics which we don't explore in our Intro to Programming course and in the Web Development course. So here, if you're here today, you can find out more of the math involved with some algorithms and some other cool things involved as well. And in general, we're here to have a good time. So thanks for joining us. And without any further ado, let's get straight to it. So today's main topic, which we will be talking about today, to give you guys a quick sneak peek / a hint, is that we're going to be continuing on that idea of the clustering algorithm. Now, you might remember from last time we were here together at Hack Central way back in August, was that we talked about a different clustering algorithm called KNN, that being the K nearest neighbor. However, today, we're going to be talking about something similar, yet different, that being the K-means algorithm. If you're confused right now, don't worry. We're going to be diving deeper and understanding the nuts and bolts and all that good stuff of what this algorithm is really composed of. So let's get to it. In case you don't already know me, guys, my name is Rayaan Siddiqi. I am a senior at James B. Cohen High School. I love to program. I've made various amounts of apps for the App Store, made a dozen different websites, and now really looking towards the content creation side of using my computer science skills to write articles for the internet, make YouTube videos on the side, and leading a talk show as well with some of my friends. So if you're ever interested in seeing what I've been doing, see my latest project, you're always more than welcome to check out my website at RayyaanSiddiqi.com. All right, and you might remember me talking about earlier today some of the other programs which we have going on here at the Schaumburg Library, which are very awesome, and you should definitely think about participating if you are here joining us today. The first being the Tech Bytes program, through which we teach computer science programming languages. So on Monday specifically, we have our Intro to Programming course from 3 to 4 p.m. And then on every Wednesday, we have our Web Development course every Wednesday from 3 to 4 p.m. In our Intro to Programming course, you can come and learn about the language of Python. We have actually been doing this now for almost 3.5, 4 months almost now. It's crazy how time flies. We started way back in the early months of June and have now made a lot of progress and are now making really nice projects. So if that sounds interesting or appealing to you at all, I would highly recommend that you guys come join us, check it out. If you like it, you can stay. If you don't, no worries, you can leave. And yeah, it'll be a great time. And another program which we have going on here is every other Friday, meaning a bi-weekly program, we have a game of Teen Trivia Online. And although this is a bit of a typo, we don't do gift card prizes anymore. We do have an awesome leaderboard through which we keep track of the latest and the best placements, people who place the highest every week. So yeah, we are not doing gift card prizes anymore, but still having a lot of fun. So if you'd like to join us, you're more than welcome to join us for that as well. All right, so let's get down to today's topic, that being the machine learning algorithm, which we will be talking about today, that named the K-means algorithm. Now, if you think, hey, I've heard something to do with the letter K, well, you're right. If you were here last time in August when we did our Hack Central event, we were talking about the K nearest neighbor algorithm. However, today it's a bit different, but we'll go over all of the similarities and differences of the two algorithms. And today we're going to be talking about this algorithm called the K-means algorithm. Now, you might be asking, what programming language are we going to use to implement this algorithm? Well, what the language we've used the past 2 times, that being Python for the 3rd time again. Now, we've previously talked about that Python is a really nice language to implement machine learning, especially because we can manipulate our data, and the key point being that we can visualize it very nicely. And that'll be something which we go over today. And you might be reading some of these names which sound pretty foreign, like NumPy, Keras, TensorFlow. Are these even English words? Well, yes, they are English words. They are called modules or libraries, which we can use in conjunction with the language of Python in order to implement machine learning models and algorithms. And if you are here from the Intro to Programming course, you're like, hey, we're studying Python. Can I do what I'm going to show today in Python? The answer is yes, although we're not at that point where we're going to be doing machine learning algorithms in our Intro to Programming course. This is definitely one of the extensions and something in the future after we get down a couple more months down the line, something which we can explore on a lighter level. But today is not meant to foreshadow or signify that this is what we will be doing in our Intro to Programming course. So it just goes to show us that our languages, which we study each and every day in our courses, really have a wide outreach and can have multiple impacts. And I got a little note here today saying that we will be using a module called the sklearn module in order to get a data set. I'll be talking about more of that today, but just to give you guys a quick hint / preview of what we will be going down today. So let's talk about what does this algorithm actually do? Well, earlier I remember I told you that this is a clustering algorithm. Essentially, it is a way for us to make classifications given a certain data set. So if you remember last time we had that cars data set, we were telling the computer that, hey, we have some features such as if a car has a number of doors, how many people can fit inside of it, all that good stuff. And then we wanted the computer to classify the car as whether it is a safe car or it is not a safe car. And essentially, it's the same concept today in the sense that we are still going to have some data points which we want to be clustered and classified into one specific area. Now today we will be getting a bit more mathematically advanced, doing some geometry. I don't know if you're a fan of that, but nothing too advanced. Hopefully you should be able to keep along. I'll try my best to explain it. The math is, if you were here last time, is pretty similar to the K and N math, but that is to be shown later. And then basically this algorithm, in hindsight, the main thing which I want you guys to take away is that this k-means algorithm allows us to cluster data. So if you look at this image I got towards the right here, we have this comparison showing us how data points look before and then after we implement this algorithm. And as you guys can see, before we implement the algorithm, we have a lot of data points just out on the freeway, essentially on a X and Y grid, right? Well, after we implement the algorithm, we see that all of the data points are correctly clustered depending on whatever color they were. So if we look towards the right here, we can see that blue is in one area, yellow, orange, red. They're all in the respective area and towards the nearest data point. So we look at the blue one, for instance, all of those points inside of that blue circle are all blue. Well, there's a reason why that happened. It's because this algorithm allows us to cluster, aka move data points together into one specific area depending on their features. Now, if you were here last time, you might be getting confused. Wait, we learned about something called the K nearest neighbor, and now we're learning about something else with the letter K? How many Ks are there? Well, nothing to be too worried about. These two algorithms, we're going to be talking about their similarities and differences, but in order to differentiate them, we have to think about something called supervised versus unsupervised machine learning. Now, you might remember that K nearest neighbor algorithm from last time. That was a classification algorithm as well. However, the key difference is that the K nearest algorithm, which we talked about last time, was a supervised machine learning algorithm. And what we are learning today, that being the k-means algorithm, is instead an unsupervised machine learning algorithm. So let's take a couple steps back. Let's talk about what is the difference between supervised and unsupervised machine learning. Well, I want you guys to remember that car example, which we did last time. In case you remember, essentially the example which we did with our last Tech Central was that we classified a car to be safe or not, given some features, such as how many luggages can a car fit, how many doors does it have, how many passengers can it fit, what's the condition of the car, and the price. So what we were doing was that we were passing in all of those features into the K nearest neighbor algorithm because we wanted to classify the car as safe or not safe. However, when we were doing that algorithm, we were also passing in the safety rating. So we knew beforehand if the car was safe or not safe. Now, here is where the major difference comes into play with the k-means algorithm, that being that the k-means one is an unsupervised type of model of machine learning, because we are only, in the car example sense, we are only going to pass the features of the car and not the safety rating of the car. So to put that into simpler words, essentially we're going to pass in those details of how many doors, how many passengers can sit in the car. However, we're not going to tell the algorithm, is the car safe or not? So we're essentially putting the algorithm on its own, essentially in the forest, think about it in such a sense that we're telling it, hey, we want you to come up with the labels by yourself and classify it and make predictions essentially of how and where data points can be clustered into. Now, this is a very large concept, which I'm simplifying down today, but the main thing which I want you to take away from this point of the supervised versus unsupervised machine learning algorithms is that when we have a supervised algorithm, we know essentially what the output is going to be because we are passing in the output of the classification. So we're telling it what labels should match how the data points should be clustered. So think of it like this, essentially, that we have in supervised machine learning algorithm, we are telling the computer how we want our data points to be clustered. However, in an unsupervised algorithm, we are not telling the computer how we want them clustered. So for all we know, the computer could come up with its own way and classify them based on something else. It couldn't even be safety or not safe, safe or not safe. It could be a whole new category of based on how the computer classifies our data points. Hello? All right, so now let's go over the similarities and the differences between these similarly named algorithms, all right? So let's start off with the similarities. What do they have in common? Now, they are both algorithms which are classifying data. Remember that point which we made last year about classifying versus predicting data? If the first time we talked about an algorithm called the linear regression algorithm, well, that allows us to make predictions based off a line of best fit. However, with these past two algorithms, they are used to cluster and classify data points into a certain area, into a certain category, right? And another similarity which they have is that both of these algorithms are not really that efficient for classifying hundreds of thousands of pieces of data. That being because they are not that computationally efficient. They take a lot of time to run. I'll go through an example today. Hopefully it doesn't take more than a couple of seconds, but the example which I'm going to be doing is just using, say, about 50, 60 data points or 100, near that amount. Think about larger scaled operations when companies are dealing with millions of data points, millions of different pieces of data, and classifying that, well, it can get pretty long and tiresome. So this algorithm is not generally suited for that purpose. However, let's talk about some of the differences. So the main difference is that what we talked about in our previous slide. That being that the k-nearest neighbor algorithm is a supervised machine learning algorithm, like we talked about previously. And then the k-means algorithm is an unsupervised learning algorithm, which we established because we know that the k-nearest neighbor, the supervised learning algorithm, that tells us that that we are passing in the output, aka we are telling the computer how we want the data points to be clustered. But in an unsupervised algorithm, we're not telling the computer how we want our data to be clustered. Something pretty cool to think about. All right, so let's talk about a visualized example and put this algorithm into perspective. We've done a lot of talking, used a lot of big words today, but let's get simpler and think about it in a simple sense and visualize how this algorithm actually works. So we have this example right here with the k-means algorithm. We want to classify these red colored dots as one color. We want them either pink or yellow. So just imagine that these dots are right now colorless. If I made them colorless, you cannot see them on the page. But imagine that they're colorless right now, and we want to make them either pink or yellow. Now, first, like the k-nearest algorithm, we have to determine a k-value, that being the number of data points which we will examine to make a final conclusion to determine what color each data point is going to be classified as. So in this case, we're going to go with a k value of 3. Remember, it is usually better to choose a k value which is odd, because if we have a k value which is positive, it can get a bit tricky when we have for one color for the other, deciding which feature we want to classify our data points as. So once we have this basic idea down of our k value and then how we want to cluster our points, we have to place 2 shapes onto the board. So we have this XY plane right here, and we have these data points. Then we're going to place 2 random shapes. They are often referred to in computer science as centroids because they're placed from the center, and then they are placed in random positions over these data points. So essentially, the computer places them wherever it likes to, and there's no math or science going on right now because it is just purely random of where the first shapes, right now it looks like we got some squares, being placed onto the plane. Then each point which we have, so each of our data points, is going to be clustered according to one of the centroids. So essentially, we're trying to classify each point as either pink or yellow. So each of these points, we essentially have a line drawn straight in the middle, and then each point is going to be classified as either being yellow or pink. So looking at the 3 nearest points, because we have our k value of 3, then our algorithm essentially clusters each point. So if you take a look at the circle which I made around each data point, we can see that most of these points are correctly clustered, aka they're correctly classified to be yellow or pink. So all the points nearest to the color yellow, they're classified as yellow, and then all the points nearest to the color pink, they are pink. However, there seems to be one extreme outlier value. In that case, the algorithm will need to run again. So what does that mean if the algorithm needs to run again? Well, essentially what happens is that the centroids, as you can see, they're placed into another random position, and then the classification happens again. So then we evaluate the nearest data points, and then the algorithm clusters our points again until each of these data points are classified to the nearest shape, aka the nearest centroid. So this algorithm will keep on running until all of the nearest points to the color yellow square are classified as yellow, and then same thing applies for the pink square and the pink data points as well. All right, so every time we do our Hack Central event, I like to take a look at some of the math behind the algorithm, and I like to do the same today. So let's open up the whiteboard. There we go. All right, so today we're going to be going over the math of the k-means algorithm. And if you were here last time, you'll see that it is pretty similar to that of the k and n algorithm. All right. So let's get the tool out. There we go. All right, so we have, say, I'll draw some random data points. Say we'll just call these random points, treat them as the color blue, like such. And then we randomly place 2 different centroids onto the map. So say we have one triangle right here, and then we'll place another triangle right here. Actually, I should probably draw them in different colors so that we can get that nice visual effect. So one triangle right here, which is yellow, and then the other triangle right here, which is a darker shade of blue and such. Now, in order to classify each data point, whether it is a blue or it is a yellow data point, we have that line drawn straight down the middle right, but that's just for visualization purposes. In reality, what is happening is something called the distance formula. If you don't remember what the distance formula is, essentially we're evaluating the distance between 2 points. So in this case, we're evaluating the distance between this centroid and a data point. So how that formula runs is that I'm going to type it out to make it simpler. We have our first coordinate, the first x coordinate minus second x coordinate squared plus the difference between the y coordinates squared, all under a square root. And then essentially what our computer is doing, this algorithm allows us to check for the distance between each data point and then the nearest centroid. And then whichever, so say we'll use this point right here. Now we can tell that obviously this point is closer to the yellow centroid, the shape, but to put it in mathematical perspective, our algorithm is going to check if the distance between this point and this centroid is smaller than the distance between this point and this centroid, then it knows that this point will, in fact, be classified as a yellow point, like such. Now, this is the watered down version of the mathematics. There is a bit more math which usually goes on. That being that there is usually a sum taken along with some derivatives happening. But I do not want to go too much into depth to lose anybody. But the basic gist is, if you've taken an algebra class, you know what the distance formula is, and the logical sense right here is making sense as well. That we are looking that whenever there is a shorter distance, then we know that our data point will be classified as that shape and as that color, right? So that's the basic math behind how our points are clustered. All right, so for this last activity of today relating our new k-means idea is that we will be having a scenario in which we are going to classify a data set of handwritten digits 1 through 9. So essentially we want to look if the computer can correctly identify certain digits if they are 1, 2, 3, 4, 5, 6, 7, 8, 9, you know the case, right? And we're going to be loading up a Python script and I'm going to show you how it's done. So let's run the example and visualize how we can classify handwritten digits. All right, there you go. Hopefully you can see my Python environment right there. So we have learned about that usually we have some imports. Remember, these are libraries, modules, which we can use to help us code. And one module which I want to point out today is this sklearn module. This is a library which is super helpful because essentially it allows us to get the data set. This sklearn model is super nice. I'll show you in a little bit something else I can do as well. But firstly, it allows us to load in the data set of the digits. So we are essentially treating those digits as our data points, which will be clustered. Now, this line of code right here allows us to essentially degrade our data. Because if you think about it, handwritten images of data, that's going to take up a lot of space. So we want to convert those huge values as features into smaller and watered down versions so that we can train our model quicker and so that it is more efficient and accurate. In order to do that, we essentially use this line of code in order to convert our data into a range between -1, 0, and 1. So that range being between -1 and 1. And then that way we can much easily compute and make our model. And then we go down here, we have declared our k value. This is the number of points we are looking at from last time as well. And then this is a function which I did not write. This is from the sklearn's website. If that sounds familiar, yes, that is the import we just used. This website allows us to use the k-means algorithm, and it's a bunch of code which I'm not going to explain and go into detail with, but I will go over this last line before we run the program. This last line allows us to actually use the classifier, meaning that this line is actually where all the awesomeness is happening, where the clustering and the classifying is happening. So if I hit run, we can see this algorithm run. There we go. So remember the idea that this algorithm is not that computationally nice, meaning it takes a lot of time to run? Well, we sort of saw that in play right there. It took approximately 3 seconds to run. but that wasn't with how much data. Say we have much more data, hundreds of thousands of pieces of data, hundreds of thousands of handwritten digits. Boy, that can get really long time. So right now we have this weird output in our output box, which may seem a bit foreign, but this is just evaluating and looking at the certainty and essentially classifying each digit into its respective cluster. Now, besides me explaining what these numbers mean, I think it'd be better if we visualize them and develop that visualization, right? So I have written, there is this other script which we have right here, which is using that awesome library, remember, called matplotlib, which allows us to visualize our data. So this is a bunch of code I'm not going to go over. The main thing is that I want you guys to be able to visualize how the algorithm works. So if I hit run, we see some stats being outputted. I'm going to switch my share on my screen to that. Hopefully you can see this figure like such. And this is a way where we can actually visualize our data so nicely with Python. As I mentioned, this is one of the very big advantages of using Python with machine learning, because we can visualize our data set. And here we can actually see our centroids. Remember those shapes? We see them being placed into each of these random areas, and then they are being placed into more random areas until each of the data points are correctly classified as the respective color. So as you can see that we are representing the centroid as these white X's, the white cross marks, and then we have a bunch of different colors, and then we are classifying those colors depending on their features which we passed in. And I think this is just a pretty cool and awesome way to see that all the stuff which we talked about today, it can be translated into one simple picture to recap the whole idea. In this sense, we can see how each data point is being classified and clustered into a color like purple, red, orange, yellow, green, all that good stuff. And we can, if I zoom in actually, which I don't think that has the capability to do so, but we can see that a lot of the colors are clustered around this teal slash aqua color in the middle. So that is just another cool way to see the reach of our program and algorithm as well. All right, guys. Well, that was a bunch of information, but a lot of cool and interesting information which we went over, comparing our old algorithm, the k-means one, to the new one, the k-nearest neighbor one, to the one which we learned today, that being the k-means algorithm. We went over an example, talked about the algorithm in depth, the math behind it, and then ran a visualization as well. Hopefully you guys had a great time. Although this may sound a bit scary, some of the stuff I'm talking about, nothing to be afraid of. We will definitely not be doing this in our intro to programming course. Hack Central is just a way for us to dive deeper into some topics like the k-means algorithm. So as always, I hope you guys had a good time. Tomorrow we will be having our web development course. So hopefully if you caught some interest today, I would definitely love to see you guys there tomorrow. But other than that, I hope you guys take care, and I'll catch you guys on the next one. See you guys.